Okay, good evening. Welcome to
MinuteMath98.
MinuteMath number 98. Today we actually have a really neat problem from the Mathematical Association of America's MinuteMath page. And it's an interesting geometry problem, and it shows that not all math problems are just about crunching numbers, because there's very few numbers in this. The question is, what is the minimum number of squares that must be colored black so that the large square, ABCD, this big square, has BD as an axis of symmetry? Okay, so do you know what axis of symmetry means?
Well, it means if you cut something in half, then these two sides are equal.
Well, not that they're equal, it means that they're the same. So if I had a piece of paper, for example, and it had an axis of symmetry right down the middle, kind of like what you've drawn, it would mean that if I had a black dot sort of here near the edge, that I would have a black dot over there near the edge. Okay?
Yeah.
So that when I folded them over, those two black dots would be right on top of each other. Okay? Now, it also means, now can you draw the line BD for me in this picture? You're going to use a different color than black, even though it says black. Fill them in black. Okay, so now for something like that, that axis of symmetry, let's take a little bit of folding here by me. That axis of symmetry means if I have a dot up here, that's going to correspond to a dot down here, so that when I fold over, those dots are right on top of each other, right?
Yeah.
Okay, so that's what axis of symmetry means, sort of. Okay, so can you show me a square that has to be colored in to make that line BD an axis of symmetry?
Well, this one,
Okay, why?
because it corresponds to this one.
Okay, so that if I folded this over like a napkin, this square would fold over right onto that square, right?
Yeah.
Okay, so maybe the minimum number is 1.
We also have to color in this one.
Okay.
For this one.
Okay, if I fold it over like a napkin, this square would be right on top of that square to make it an axis of symmetry. I noticed that our line, or I didn't draw this quite right, it's supposed to go right through there, right?
Yeah.
Sorry about that. Okay, what else? So maybe the minimum number we have to draw in is 2.
We've also got this one to correspond to this one.
Okay, so maybe the number is 3.
We also need this one, so the opposite of that one's here.
Okay. Alright, so maybe the minimum number is 4.
So we have one to correspond here, 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 here. But this one, you just fold it in half.
This one folds right onto itself. Okay, so there you go. Now I have the top and bottom are exactly the same if we pretend that the purple squares are black. But I wanted to draw them in a different color so that you could see, right?
Yeah.
So when I fold this over now, I have a perfect axis of symmetry on this line BD. So I needed to color in 1, 2, 3, 4 squares. Good job. Only 40% of the people got that right. That's a tricky problem. All right, good job tonight, honey.